It plays this back better than a Threadripper Pro 64-core CPU that costs about, just the CPU on its own will cost like about 3 times as much as the whole laptop over here. Welcome to Tech Notice, my friends. So I got a request of doing the actual video playback test with this Asus Zenbook Pro 14 DUO OLED laptop as well. So what I want to know is, even though just having the integrated Xe graphics from Intel plus the i7-12700H processor, is that enough to actually just edit some video on this? Well, let's find out.
Motion Array is a fantastic tool for creators to make better videos and faster.
Motion Array has over 600,000
premium quality templates, presets, plugins, music and sound effects, stock video and photos. In a nutshell, it is a one-stop shop for all your video post-production needs. Configure the membership to suit your needs. Pay annually, monthly, cancel anytime you want, and enjoy your unlimited downloads. Not sure about Motion Array? Go try out the hundreds of free assets available on the website. Check out Motion Array in the video description below.
So then, a few things first then. First of all, might not be able to do it exactly as I do it on my usual video recordings. So I am recording the external HDMI output. I'm not sure how much this affects the performance of the laptop as well, you know, like while recording like another screen over there. At the moment I'm mirroring this like main screen in here, and as you can see on the back there on this camera, you can see that's the other input that I'm recording externally. I'm just going to keep this camera rolling still as here as well, because previously a little bit of an issue before actually trying this, before recording this video. By the way, if you haven't seen my unboxing review and long-term review of this, then go check them out on the channel as well as this laptop. If you want to check it out, I'll leave it in the description below. By the way, the upper camera here records the task manager on the second screen as well as hardware monitor on the left side here. So I'm going to reset all the values here. That's what we can see. By the way, this little kind of line in here, if you see this going red on the very left column, that means it's thermal throttling right there and then. If the average there or maximum is red, that means that it has thermal throttled, but it's not thermal throttling at the moment. So if this one over here is thermal throttling, it will go red. You'll see that in a moment. So first of all, we've got this Premiere Pro project open over here. We're going to try with normal mirrorless camera footage, which is 8-bit 420, 60 frames per second, 4K. Okay, I'm going to press play. Bear in mind, this is full resolution. And then look at that, 0 frames dropped. Our Xe graphics here, the video decode, it's playing it back on the actual, decoder there. CPU is doing not much, but it's all played back on the GPU. Bear in mind, it does have 2 media engines inside the Xe graphics there inside the CPU. As you can see, video decode 1 and 2, there's 2 of them over there. So it's playing it back, no problem over here. If I'm gonna do timeline scrubbing here, it's smooth as butter, like no problem at all. If we're going to add a little bit of adjustment layer, which basically means that now it's going to start to use the actual graphics calculating power, like if your NVIDIA graphics card is uses like CUDA cores and so on there, like the actual graphics card. So now it starts to use that. Let's press play, see what happens. Now straight away it is dropping frames here. It's not playing back it at full resolution. Bear in mind, this is full resolution, and I doubt you really edit this on full resolution as well. But as you can see, the 3D here is 100% going. It's just interesting to see that type of analysis there. Now, if we do drop this down to like half the resolution, I'm curious what's going to happen there then. Look at that. It's playing it back, 0 frames dropped. So you wouldn't be editing it, and look at the timeline performance as well. Very, very smooth. Bear in mind, we have thermal throttled. Our CPU has it 101 degrees there. This is 10-bit now. Let's see if that is any different. If it's 24 frames per second, 10-bit 420, so this is not 60 frames anymore. Look at that. We're playing back full resolution, and the adjustment layer is on as well. So it's actually, you can do some color grading on this. Look at that. I'm very impressed actually. Let's move on to 10-bit 422 30 frames per second. This should be CPU only codec, and the GPU shouldn't be able to actually decode this. So let's have a look if this is the case here. As you can see, yeah, video decode doesn't happen on the actual GPU, but now the CPU should be playing this back. Although we still are using 3D a little bit there on the GPU side of things, but we're playing back full resolution, 4K, 10-bit 422, 30 frames per second, no problem. I am quite impressed. So now I'm gonna put the adjustment layer on as well. Let's see what's gonna happen there now. As you can see, 3D, which is like the graphics performance kind of indicator over there, we're running like literally 100% there. We are dropping a few frames at full resolution. Come on, this is full resolution, but to my eye, it's not that bad of a playback, right? I could easily edit even at full resolution, but putting it at half resolution, 10-bit 422, 30 frames per second. To be honest, I'm impressed that you can do that on the laptop. That's quite ridiculous. We are thermal throttling as we are playing this back, as you can see. It says yes there, so we are, you know, pulling it down. It pulls the clock speeds down. So this is 10-bit 422 at 25 frames per second here. I'm gonna play this back at half the resolution here because this is a little bit a hard codec to play back. But at half the resolution, look, it's the CPU that will play this back here. And bear in mind, this is with the color grade on at the moment as well. To be honest, I'm quite impressed. If I look at the timeline performance, yeah, it is a little bit choppy, but it is one of those choppy codecs that you have to get used to. But when I'm pressing play at half the resolution, it does play it back no problem. Now, the second clip over here is an SI or all intra clip, which is basically less compressed. It's a little bit easier to play back on any of the hardware systems. If I'm scrubbing through here, it's very, very good. Now, in here, I want to put this at full resolution, see if it plays back. Look, no problem. 0 frames dropped. We are thermal throttling, running 85 degrees there. It is pulling down the clock speeds there a little bit, but it is playing it back no problem, even with 16 gigabytes of memory here. I'm seriously impressed. This here is 60 frames per second, 10-bit 422 from Sony A7s2. 3. And as you can see, we're dropping 0 frames at full resolution, which is quite impressive. Bear in mind, this does go on the CPU rather than on the GPU, but because of the 14 cores inside there, you can actually play this back. If I'm putting the color grade on now as well, now that gets proper choppy. It's not able to play that back anymore. As you can see, CPU gets very much maxed out over there. We're pulling about 70 watts through the CPU with thermal throttling, 96 degrees. It's not a good idea. If you do drop it down to half the resolution, still 60 frames per second, 422, it's a nutcracker there. Now this is 50 frames per second, still 10-bit, 420 4K, but because it's 420, it should be hardware accelerated from the video decode over there. I can already see, video decode is working there. It's full resolution, so it does have hardware acceleration for this codec here. We are dropping some frames even at 50 frames per second here, but to be honest, it's still, like, to my eye, it looks quite normal there, no problem. Timeline performance very, very good, so I think there's no problem with that. Now this is interesting. I'm curious how this is going to work here, because this is 4K 60 frames per second 10-bit 422 H.265 codec. This usually is a big nutcracker for any of the devices that don't have hardware acceleration, even that run like NVIDIA graphics card. But as you can see, now it uses a separate media engine there. This is probably the H.265 media engine there. Actually, look, it changed the media engine as well. Moved from one to the other one. It's decoding from the other side, but we're playing back full resolution and it's got no problem doing that. It's that's truly amazing. And this really shows how important it is to have H.265 and 4 codecs on the actual CPU. Now, this is very small laptop, and I did not expect this to do as well as this here. But look at that. The timeline performance is buttery smooth. It's as smooth as on a 12900K or something. So if you do want to edit video, you can completely do that. I'm going to put the adjustment layer on as well. This is a little bit of a different situation because it does use the graphics power, but because they integrate that XE graphics there, they don't have a lot of like graphics computing power or the raw power of graphics, for example in Blender and so on. That's why it's hard to play it back with the color grade. I want to put it on half the resolution. Let's see here, that look at that, half the resolution, video decode there, 100% used. So our media engines are doing its job, but it's not dropping any frames. It's fantastic. It plays this back better than a Threadripper Pro 64 core CPU that costs about, just the CPU on its own will cost like about 3 times as much as the whole laptop over here. So this is Canon C200 RAW. This is 4K 60 frames per second Canon RAW, and the timeline performance at even full resolution is very, very, very smooth. Now I can see that this all goes on CPU rather than on the decoders, but I don't expect it to play back very well, yeah, with the color grading as well especially. So I'll take the color grade off, play this back at full resolution. It's dropping frames, I can see it there, but I doubt you're gonna edit it full resolution anyway, especially on a laptop. Half the resolution, it just edits. Okay, I want to move on to a little bit harder codecs here. So this is Red 4K Red RAW, and playing it back with the color grade, it's not doing a good job. It does not like that because it does go on a CPU and GPU. It's not a good thing there. If I take the color grade off, still Red codecs, not a very good option over there. I'm curious about this though here. This is 4K 120 frames per second. This is 420 8-bit 4K, and let's see how well does it play back. Will this be played back on the CPU or GPU? Okay, because it's H.264, it's not playing it back on the actual like hardware. It goes on CPU, as you can see over there. Let's see 422 10-bit H.264. The same thing, it goes on the CPU, doesn't play back very well. Now this is H.265 10-bit 420. That should be on the decoders here. Yep, it uses the media engines inside there. I can straight away see that it's much smoother here, but the 120 frames per second is a little bit of a cracker there. And then 422, that goes back. Now that's interesting, because this is H.265 422 10-bit, and because of the Intel XE graphics, that is able to play this back using the hardware on the media engines there. As you can see, it is using that, and we're playing it back no problem. It's fantastic. It does quite a good job. So even at like 120 frames per second, using this half the resolution, very smooth, you can completely edit that. It is dropping frames, but it's doable. This is a little bit harder bits here. I'm not even going to put the color grade on. This is Red 5K playback, and this is, look at that now, CPU 100% utilized. I don't expect you to play back this here anyway. Red 6K RAW, I don't expect this to be any better. See, this is complete slideshow. Don't think we need to show any more over here. No one's got edit Red 6K RAW on this laptop, but just interesting to see if it's able to do it. What people might want to do it, this is Blackmagic RAW 6K. So BRAW is quite easy on the laptops usually, or on the computers. But here I can see 22 frames dropped. It's still dropping frames. The timeline performance is very smooth. So you can, I think 6K BRAW you can do. 2 6K BRAWs there. Take some time. It does go all on the CPU there quite a bit. It drops some frames, but it's not like uneditable. It's alright. I don't think anyone's gonna use Canon RAW. Like, this is 8K RAW now. I'm gonna press play. So then let's have a look at a little bit of the temperatures here as well, what was going on. I'm gonna move it onto the big screen in here now. So we can see that the CPU package like went all the way up to 101 degrees, right? And for laptops, it's all right. If this happens on your desktop, it's a bit of a problem. On laptops, that's just what happens. We did thermal throttle a little bit, but still we pulled about 79, 80 watts from the package. The graphics cores pulled 18 watts at maximum, so it's quite impressive graphics power if you think about that. Only 18 watts pulled, and we had all these media engines and played back 4K there. It's quite impressive to me. So now, the biggest surprise for this laptop for me was that actually, even though there was 16 gigabytes of RAM, we were able to play back quite a bit of footage. Now, I do think there's going to be a significant boost in the timeline performance when going to 32 gigabytes, just because a lot of the codecs, especially Premiere Pro, likes to use a lot of RAM and write all the stuff on memory and then read it from there rather than doing swaps, and you know, it's not going to be as fast. Now, I don't think anyone's going to go above like 4K video editing on this laptop anyway, but if you do mirrorless camera 4K editing on the laptop, to be honest, when running the benchmarks, if you saw the benchmark video, I wasn't impressed with the benchmark results, but now in the real world performance and like actually seeing how good it does, like in the timeline performance of the video editing, I'm very impressed, and I do think you can completely edit with this laptop, like simple things. I don't think you're gonna do massive things, but 4K editing, it's absolutely doable. And the XE graphics inside there, even with the integrated graphics only, bear in mind this is the only integrated graphics, it does work better than the Intel iGPU integrated graphics. So if we check, like for example a 10900K without a dedicated graphics card, just the integrated graphics, then this over here was better, just because the XE graphics actually has more EUs, execution units, which means it's got more graphics power and it is able to do that. Bear in mind, it is playing back at the same time a 4K panel, OLED panel. It's a 1440p really, 120 hertz, and another secondary like kind of 1080p panel there as well. So it's playing back two screens, then also sending a third screen out at the same time. So to be honest, I'm impressed with the video editing performance. If you do want to do some video editing, it's absolutely doable, but I'm impressed really. Let me know if you want to see this in DaVinci Resolve as well. Let me know if you want to know that in the comments section below. As always guys, thanks for watching. Likes if you enjoyed it, subs if you'd like to see more, and go check out the other videos about this laptop then to know how good this is. See you soon. Bye bye.